we will look at 4 different categories of salts. So the first one is salts of strong acids and strong bases. For example, potassium chloride and sodium nitrate. The second category is salts of weak acids and strong bases such as potassium cyanide and sodium acetate. So if you see here, potassium chloride and potassium cyanide and sodium acetate. And for convenience, I am writing the sodium the other side. And the third category is salts of strong acids and weak bases. For example, ammonium chloride and aniline hydrochloride. Fourth category is salts of weak acid and weak base. Here only one example, ammonium acetate, CH3COO NH4. Now why this KCl is being called as salt of strong acid and strong base? So just I'll explain you. For example, KCl is formed by the association of potassium hydroxide with HCl. So the reaction of potassium hydroxide with HCl will give you KCl, potassium chloride. Okay. So potassium hydroxide is a strong base and hydrochloric acid is a strong acid. So potassium chloride is the salt of strong acid and strong base. Similarly, you can justify the names for all the other salts also. Okay. Now, if you consider the first category, salts of strong acid and strong base. Example, potassium chloride. When it is dissolved in water, it will get dissociated into A plus and Cl minus ion, and these ions have no tendency to react with H plus and OH minus ions of water. Why? Because the possible products of such interactions will be potassium hydroxide and HCl. That is, K plus ion from KCl will react with OH minus ion and it will form KOH. And on the other hand, Cl minus ion will react with H plus ion in water and you will get HCl. Okay. So this potassium hydroxide and HCl, they themselves are strong base and strong acid and they get completely dissociated. Consequently, what will happen? There won't be any change in the concentration of H plus ion and OH minus ion. Therefore, the solution will remain neutral. Thus, what we can say, the salts of strong acid and strong bases do not undergo hydrolysis at all. Okay. So, yes, it remains neutral. It remains a neutral solution. The next, so it will not undergo hydrolysis at all and it will remain neutral. The next category is salts of weak acid and weak strong base. So here we are going to take sodium acetate as the example. So weak acid means acetic acid and strong base is sodium hydroxide. Therefore, sodium acetate is called as salt of weak acid and strong base. So what will happen when it gets dissociated? It will get dissociated into acetate ion and sodium ion. Now the anion, that is the acetate ion, will take the H plus ion from water and what will happen? It will form again the acetic acid, which is a feebly dissociated acid. The salt will get hydrolyzed but still it will form the feebly dissociated acid. So now what will happen? The H plus ion will be taken up by the acetate ion, whereas the OH minus ion concentration will go on increasing. Okay. So acetic acid is a feebly dissociated acid and then OH minus ion concentration will go on increasing. Therefore, the solution will become alkaline in nature. Okay. Now, the undissociated water further dissociates to maintain the constant value of Kw. You already know what is Kw. It is the product of H plus ion and OH minus ion concentration. So in order to maintain this constant, the OH minus ion concentration goes on increasing and the solution will remain alkaline. You have to explain it in that way. Now we know that it's undergoing dissociation. The next one is we have to see what is the hydrolysis constant for this kind of salt. So hydrolysis constant, it is usually denoted by Kh. Now we will look at the hydrolysis constant for sodium acetate ion. So if you see here, KCl will not dissociate at all. So we are not going to look at the hydrolysis constant for KCl, whereas this this one, the second category, sodium acetate, it will undergo hydrolysis. So we will look at the hydrolysis constant for this category of salt. So CH3COO minus Na plus, when dissolved in water, sodium acetate will get dissociated into acetate ion and Na plus ion. And if you see the product side, both the Na plus ions are same in the reactant and product side, so we are cancelling that one, and you can write only the remaining things on the left hand side and the right hand side. So applying the law of chemical equilibrium, now the hydrolysis constant Kh is equal to the concentration of the product divided by concentration of the reactant. So what are there at the product side? OH minus ion and acetic acid, and on the reactant side it is acetate ion, CH3COO minus ion. Okay, so let us keep this as equation.